Today we're solving the last problem, or problem 25 from the AMC 10B of 2022. So let x0, x1, x2, ... be a sequence of numbers where each x of k is either 0 or 1. For each positive integer n, define s of n as all of this, the sigma of k to 0, k equals 0 to n minus 1, and then this is the formula x of k times 2 to the power of k. And then we suppose that 7 times s of n is equal to 1 times the mode of 2 to the power of n for all n is greater than or equal to 1. What is the value of this sum? Or rather, the sum x of 2019 plus 2x of 2020 plus 4x of 2021 plus 8x of 2022. Okay, how do we even get these numbers in their base? Well, just to recap, this sigma notation is just like, it's basically adding. This is an n minus 1 here. So basically, if we want to get a number such as 2019, we have to add the next integer number after it, and then, because it subtracts 1, it becomes the last number. So, or the number before it. So, let's actually do that. To get 2019, we have to do n minus 1, where n is 2020. So, let's do this. S of n, this is equal to sigma, still have to use this here, and then this is k, still 0, and then 0 to 2019. Oh wait, it's not n, this is 2020, because n minus 1 here. And now this is still x of k times 2 to the power of k. Okay, so we have this. And basically, a sigma notation, if you don't know, this is just a fancy way of like adding all the numbers here. But there's a base here, but we can do that. This is k0 times 2 to the power of 0 plus k, not kx, x1 times 2 to the power of 1 plus all the values until you add the last one, which is x to the power x of 2019 times 2 to the power of 2019. Okay, now let's just look at something of this last term. We have the x of 2019 part here, which is what we want. But there's also something here that we kind of don't want. This term being multiplied here, or multiplying it, 2 to the power of 2019. In order to get rid of it, we can factor it out. So we know what we're factoring out, and then, well, it's just good to keep in mind that this is what we're factoring out. Alright, so let's continue. S of 2021, well, we can, basically simplify this a lot. Basically, it would be all the terms from x0 times 2 to the power 0 times the last term, which has a 2020 now, but we can just save a lot of time and energy by just writing s of 2020 plus x of 2020 times 2 to the power of 2020. Because it's just adding one more term, and the term is after this term here, if we're adding the next term after it. So what we still want the 2019. So we have to get if we're gonna factor out the 2019, we don't want any more 2's here, and we also want this value. We can rewrite it as 2 times x of 2020 times 2 to the power of 2019. We just took out 1 2 from here. When we multiply this 2 back, it's still 2 to the power of 2020. We have another one of these, and then we can keep on going. S of 2022, this is S of 2021, plus, I'm just going to write x of 2021 times 2 to the power of, well, we can do the same thing, 2019 this would be 2021, but now we take out 2 2's to get the 4 here and the 2019 here. So 2 times 2 is 4. This goes here. Now we do to S of 2023. This is going to be our last one here. This is S of 2022 plus, X times 2 of 2019. Well, this is the same story here. Like, once we keep on doing this, we kind of see a pattern emerging. This is 2. This coefficient here is 2. This coefficient is 4. They're being probably multiplied by 2. But, like, this probably will be 8. But just to double check and clarify, this is 2022. This would be 2022. 2022 is 2019 plus 3. So there's 2 cubed here. And 2 cubed is 8. We have what we want here. All these end terms. All these end terms here is like the sum of all these end terms is what we want, but like without the 2 to the power of 2019. So we factor it out. Inside we have x of 2019 plus 2x of 2020. It's basically what that is inside the parentheses. 2020 plus 4x of 2021 plus 8x of 2022. This is what we have here. And, well, so we can actually make this equivalent to something to make it more sense. Now, what is this equivalent to? Well, these are just all the last 4 terms in S of 2023. We want to keep all these 4 terms here, but subtract all the others. So it's going to be S of 2023 minus something. It's S of something. Well, the first term we tested out here or plugged in was S of 2020. So we subtract S of 2019 because those are all of the other values in there. Now you still have to divide by 2 to the power of 2019. And our first step is complete. We successfully transformed our answer choice, our answer, into something that looks a lot more simple, I guess. There's one thing we have to realize here. We've left this second thing untouched. Now, what are our values here? S of 2023 and S of 2019. Let's start with S of 2023. S of 2023. We just plug it in here. Well, we have to multiply by 7. And then this is 1 times the mode of 2 to the power of 2023. Now, there's these formulas here where this is equal to, this is basically equal to 2 to the power of 2023 times some constant, some number x, let's call that, and then you have to add 1. Yeah, I like that. Now we can do the same thing for 2019. 7 times S of 2019. This is 1 times the mode of 2 to the power of 2019. And using that formula, we get 2 to the power of 2019 times another number, which is not x, y, and then plus 1 again. Okay, so we have these values. We can get the values of S of 2023 and S of 2019 pretty easily by just dividing both sides by 7. S of 2023, 3. This is just equal to 2 to the power of 2023 times x plus 1 divided by 7. Same thing here, S of 2019. this is equal to 2 to the power of 2019 times y plus 1 over 7. Alright, so we have successfully found these values here. Okay, so basically what we can do, we notice that 2 to the power of 2023 times x, well, this is essentially 1 mode of 7 because it's one more than a multiple of 7. Same here. 2 to the power of 2019 times y, this is 1 mode of 7, like that. Yeah. So basically what we can do now is we can actually use some manipulation here, I guess. So we notice that we get that 2 to the power of 2023. Well, this is equal to 2 times the mode of 7. And same thing here, except with 2019. 2 to the power of 2019. This is 1 mode 7. Alright, so, well, this is because every power of 2, it only has a cycle of 3 numbers, I guess. So from this we can plug. This is pretty straightforward now on. From these equations, we can basically put these into these original 2 equations or something. Yeah, put them into the equations, and then we get 2x. This is 6 mode 7. And then this one is y. There's only 1 here. Y, this is 6 mode 7. Okay, so we are also given another constraint here. Both x and y have to be less than 7. And, well, the only numbers that actually satisfy this that are between 7 and 0, non-negative, because it'd be weird like that. Non-negative, we get x is 3. Yeah, x is 3. And then y is 1. 6. No, 6. I got confused. 6. Now we can just plug these values into what we're really trying to solve. What we're trying to solve is s of 2023 minus s of 2019 over 2 to the power of 2019. We have the values of s and s of 2023 and s of 2019. We just plug those in and solve them. Now we have all the values we need. Well, this is what we're trying to find. Let's just write it as 1 over 2 to the power of 2019. Now we multiply it by the whatever is being subtracted. This is divided by 7. Then this is 2 to the power of 2023 times 3 plus 1. X is equal to 3. That's a 3. Then you subtract it. 2 to the power of 2019 times 6, since y is 6. And then you have to add 1. We see that a few things cancel out. For instance, these 1's cancel out. Well, we also see that when we factor out a 2 to the power of 2019, we can't do that. This is just minus 1 times 6. Okay, I'm just going to write it like this. 1 over 2 to the power of 2019. When we make it a common denominator on the 7, and then factor out a 2 to the power of 2019 here, we have, well, to make this 2 to the power of 2023 times 3, 2 to the 4th times 3, and then you subtract 1 times 6, or 6. Now, we factor this out. Those cancel. We just get 2 to the 4th times 3 minus 6, which is, well, this is 48 minus 6, 7, which will give us our answer, which is 6. We have done the problem.